Good morning, everyone. This is the second video of today. It is to do with our science learning about forces, and in particular, we're looking at gravity. This picture of Isaac Newton will become more relevant later on. Our aim today is to try and explore the effects that gravity has on objects and how the first theory of gravity was developed. This is going to tie into our investigation, which we're going to start tomorrow. Just maybe as a warning, but something you might need to think about is on Wednesday we're going to need some paper, ruler, pencil, and maybe some paper clips or blue tack if you've got it. Don't worry if you don't know, but paper and a pencil and ruler will be quite handy. So see if you can get yourself some of those. Anyway, the success criteria today is to try and explain the effect of gravity on unsupported objects. Explain Isaac Newton's role in developing the theory of gravity, and to we're not going to do that last one, so don't worry about that one. So let's have a look at this first bit. So try and find in your house an object that if you drop it, it won't break. So a ball it'd be quite useful, or maybe like a little a pillow or something soft. Anything that you can drop that's not going to break or hurt or damage anything. Okay, I'll pause it there. See if you can. Pause the video. See if you can find it. Okay, hope you've got something. When you have that ball or that object, these children are discussing why a bouncy ball falls down rather than falling up, sideways, or staying still. Which children or child do you agree with? Okay, so I'll read them out to you. So this girl thinks there is no air resistance acting on the ball, so it can go straight down. He thinks that the ball falls downward because gravity is pulling it down. She thinks that the ground exerts a force on the ball so that the ball is magnetically attracted to the ground. And he thinks the bouncy ball falls downwards because it is heavy. If it were lighter, it would float away. Okay, have a little think. Who do you agree with? Pause the video and have a think. Okay, did you do that? Who do you agree with? Let's see what the answer is, shall we? So, hopefully you agreed with this opinion that gravity pulls the bouncy ball downwards so that it falls down. There was some air resistance with the ball. It's not magnetic. And if it was really light, filled with something like helium, then it might float away. But other than that, it would still fall down. So gravity is the force that means that the objects are pulled towards the centre of the Earth. We hopefully remember that from yesterday. All objects exert a gravitational pull. So even that ball has its own gravity pulling things towards it, but it's so small, it's almost, you can't see it. However, the strength of an object's gravitational pull depends on its mass. We'll talk a bit about mass in a minute. The Earth is a huge object, which has an extremely high mass, so its gravitational pull is very strong. That's why the moon kind of goes around the Earth. We have gravity that keeps it rotating or revolving around us, orbiting around us, I should say. The force of gravity keeps us on the ground, and gravity also causes objects to fall down if they are dropped. So, this is Isaac Newton. Do you have any idea why he is pictured next to an apple tree? Pause the video, see if you can think to yourself, why is he pictured next to an apple tree? Okay, did you do that? Let's have a think, shall we? Isaac Newton famously developed his theory of gravity when he saw an apple fall to the ground from an apple tree. So although gravity obviously exists and everyone knows it, and it doesn't matter whether you know about it or not, it exists, he was the guy that kind of created the theory about gravity. So what we're going to do now is I would like you to try and pause the video in a moment. I want you to read through the Newton and gravity fact sheet, which is in the folder for today, for day 2, about his life and his theory. then answer the questions on the Newton and gravity activity sheet. So if you go to that folder, this is how it looks like on my computer. So you've got the comprehension there, and then you've got two types of questions. Actually, I'll show you the comprehension first. So the comprehension should look like this. It's just one page. It talks about his life and his theory about gravity. And then you can pick which one you want. So there's a super challenge. So the questions are a bit easier. So you can pick that one. If you want to try a bit harder, there's questions that are a little bit harder. And each one has the answers with it. So do the questions, and then you can look at the answers and mark the answers yourself. Okay, so pause the video there and do that sheet. Okay, welcome back. Hopefully that went all right and you didn't struggle too much. Again, if you've got any questions, you can ask me on Dojo. I'll see if I can help. So let's move on to the last few bits. So we're just going to talk about weight and mass. So people often use the words weight and mass to mean the same thing. When we talk about weight, most of the time, we're actually really talking about mass, because that's the measure of the amount of stuff inside an object, and is measured in kilograms. So, for instance, I'm 70 odd kilograms, maybe 73 kilograms. That's my mass rather than my weight, because weight is actually a measure of the strength of gravity acting on an object, and it's measured in newtons. Now, if we were in school, we'd do an experiment with a Newton meter, which you kind of hang things off, and it tells you how many newtons is acting upon it. But we can't really do that, so I've cut that bit out. But we will do an experiment later in the week. So the weight of an object is caused by the gravity pulling it down. Objects of more mass have a greater weight, as the force of gravity pulls them down more strongly. So the thing about weight and mass is that your weight is different depending on if we travelled around the universe on different planets, our weight would change because it's affected by gravity. So an object's mass will stay the same even if it's in a place with weaker gravity, like the moon. However, an object's weight can change. So if we were on the moon, or if the object was on the moon, although it would have the same mass, so if I was on the moon, my mass would still be 73 kilograms, but because the effect of gravity is less on the moon, my mass would be less. And if I were to go to Jupiter, then it's a much bigger planet than Earth, so there's a stronger gravitational pull. So although my mass would stay the same, I'd still be 73 kilograms. The weight would be much more because the gravity is much more on Jupiter. So just remember then that the mass is how much matter or stuff is inside an object. It is measured in kilograms and grams. And weight is how strongly gravity is pulling an object down, and that's measured in newtons. Named after Sir Isaac Newton. Okay, so when you've finished everything, maybe don't worry about this last success criteria, but you can evaluate how well you've done this today on these two success criteria. So you can reflect on these. So can you explain the effect of gravity on unsupported objects? And can you explain Sir Isaac Newton's role in developing a theory of gravity? So that will kind of depend on how well you did on the reading comprehension. Okay, I hope that's helped. Tomorrow we'll do a little bit more work on forces, and then we'll start off our investigation. We've done investigations before, and we'll focus on the conclusion and evaluation rather than the planning of everything. I'll do most of the planning stuff. You can do the actual experiment, and then you can evaluate it and conclude at the end. Okay, I'll speak to you tomorrow. Bye-bye.